captions. Hello. Guys, welcome and please settle down.
Wes, what's
Especially
Roger's
people
fault?
who are on in the flea market.
What's Roger?
Our first session is going to start, and
Your mic is dead.
Yeah, okay. His call is KA7EXN.
Oh, that's right.
Actually,
okay. So this is a very special session that we are starting with. Here you can see Roy Liu Allen. Okay. For those, okay, how many people remember the handbooks from 80s and 90s? There was a small, very small 7 megahertz radio described as an optimized radio. That's him, built by Roy. He's also developed the EasyNeck antenna modeling system. Okay, that's him. And then we have Wes coming up there. By the way, can we get a better internet on that? Just see. We have got Wes, who's, invented the direct conversion radios, etc. He's the world's most famous home brewer. The first time he's coming on air, into any conference after a gap of almost 20 years. So it's a big one. He doesn't come to Dayton, he doesn't come to FDIM, so we're very happy to have him here. Right? So that's him. And I will leave it to Roy to introduce the other guests, and then Roy will take on from there. All right? Okay.
I'll have to remember to mute the mic once you get
Yeah,
started.
so all the comments you make under your breath will be
Yeah.
go out in public.
Put him okay. Yeah, you're on.
Hello, everybody. I'm Roy Llewellyn, W7EL, and I brought along a few friends, and these are people who feature in the presentation that I'm about to give. I'd like to introduce, first of all, Wes Hayward, W7ZOI, and if you haven't heard of him, you should be ashamed. His son, Roger Hayward, who is shown in some of the slides, is quite a bit younger than he is now, although, Roger, you haven't changed too much. Dave DeFord, K0ED, who I've known for more than 50 years, and we've had a weekly sched for just about all of those 50 years. And he's done field day with me many times. And Tom Rousseau, K7PJT, who also has done field day with me a lot of times. So I'll get into the presentation here, if everything works out. Here we go. Let's see. Yep, I think we're in business. Like the window or screen. It did. Entire screen. Okay, I'll say it twice. Wow. Holy mackerel. Okay, I'm sharing my screen. And what I'm trying to do here is to show my presentation. So I'm going to start it up here. And I would like some feedback. Do people see this?
I can see it.
40 years of QRP field day.
Yeah, I can see it fine here, Roy.
Okay, good. Okay, here we are. This is going to be about 40 years of QRP field days. And that's me with Dave DeFord, who K0ED, who I've done many field days with. We've run into some very vicious mosquitoes over time, so I got us these t-shirts, So Many People, So Little Time. We have learned on field day to not go and hike into places where there's a lake nearby, which is really nice because we don't have to carry in water, but we have gotten attacked so badly in some cases that we decided not to do that again. I'll have a little more about it. My experience with field day started a long time ago, 1963 to be exact. And this was the Martin Marietta Radio Club. Martin Marietta is a aerospace company in Denver, Colorado. And I was about 17 or something years old at that time, but I was a CW operator, and they always needed CW operators for their field day operation. So I was invited to come and operate 20-meter CW for them. And so I went to the 20-meter CW tent and sat down at the keyer, and they were kind of skeptical at first, but I showed pretty quickly that I knew how to handle the key and work the rigs, and so they all left and went off to bed because I was doing the night shift. And so they were in a tent, as is commonly done in field day, U.S. field day, and I got to operating, and I had a friend with me who was a technician class licensee, and he was doing the logging for me. And the setup they had was a tri-band beam on a tower guide to some sagebrush. And that's my car, my father's car there in the foreground. And that's the tent. You can see the tent we were in. I got to operating, and it got dark, and it wasn't doing quite as well as I thought it should be doing. We had that KWM2, and which was a reasonable amount of power, and there was skip down to W5, but people weren't coming back all that well. And so I thought, well, I wonder if it's possible that beam is turned around backwards with trapped beams like that, or loaded beams. You can't really tell for sure which element is a director and which is a reflector unless you're familiar with the beam, and I wasn't familiar with one. I couldn't afford a beam. And so by that time it was pitch dark. I told my friend to please go outside and turn the beam around 180 degrees and would see if the signal improved any. So he went out, stumbled off into the dark, got a flashlight, and went out. He says, where's the rope? And the beam was turned via a rope just tied around one of the elements, or the boom, rather, the boom at one of the end of the boom. And you just walk the beam around and then tied it off with a sagebrush. So he went out and said, where's the rope? And I shined my light out there, and there it is over there. And so he stumbled out into the dark. And so I'm waiting, I'm listening on the earphones, waiting for the signal to change, and not hearing anything, and any change, that is. And then I hear him muttering something about, geez, this thing sure is tight on tight. And so, oh, there, I got it. Oh, no. And then there was this kind of a big crash outside, and the earphones went dark, they went blank, and what turned out is that he had untied one of the guy ropes instead, and the tower came down, and that's the beam. And so what I did was I took the coax feed line, stuck it in my master mobile whip on the back of my car, and we used that for the antenna for the rest of the night. Once in a while, somebody would come by in the dark and say, gee whiz, we thought there was a beam here. And well, there used to be. And I asked about the owner, and he was in bed, and I didn't really want to wake him up and tell him that I had crashed his beam. And the neat part of the story is that some years went by, and I ended up returning to town after I went to school, dropped out of school, went to work, quit work, joined the Air Force, got out of the Air Force, went back to school, and my roommate ended up being that same technician guy that was a logger and that brought the antenna down. And he said he had been going to the university extension, and some guy found out he was ham, and he said, say, I understand you're a ham, would you like to buy a beam? He says, really cheap. And says, well, what's the matter with it? And he said, oh, some idiot crashed it, and it's all bent up. And of course, he didn't buy it. So fast forward to 1978, and Wes is with us, and that's Wes. Let's see if I can, let's see. Ah, there we go. there's Wes right there. And this is on the side of Mount Hood at about the 8,000 foot level. That's what, 1,200 or so, a little more, 1,300 meters. I'm sorry, 13,000 meters or so. No, excuse me. Never mind. Let's just leave it at 8,000 feet, and I'm not going to try to think straight while I'm doing this. I beg your pardon. I hope you guys can convert better than I can right now. A really neat thing here is that nice little conical mountain in the background there is Mount St. Helens. That's before it blew its top, which it did in 1980. And Wes took me up to this place on the side of Mount Hood, overlooking Mississippi Valley. Anyway, we're up there, and that's a big pumice outcropping because Mount Hood is basically a big ash pile, as most of these Cascade Mountains are. And it's just all fine, gritty pumice that we were on. And I had this backpacking tent that I just gotten used for the first time there. And we set up camp, and we set up a little vertical antenna. Let's see, I think I got a picture of the vertical here and another one. Wes had we set up a vertical, excuse me, what we did is we set up an inverted V antenna for 40 meters using a piece of aluminum pipe, swaged pipe that you could stack for a mast. And Wes had a homebrew rig. I don't know, ran a couple of watts as I recall. And we operated for quite a while and worked a few stations. We didn't work an awful lot of them because it turns out that we were kind of poorly placed on the mountain to reach the real population centers in the US. But it was a lot of fun. And then after it got dark, or as it was getting dark, the wind came up. And you can see the tent, what the tent looks like now, right here. It's totally inflated. This is our mast right here. We ended up having to get up and put some more guy ropes on the tent to keep it from blowing away. And I still remember waking up in the middle of the night when a big gust would hit, and the tent would be going flap, 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 flap. And I thought, this time this thing is going to go over. And it never did, but I really was in fear of being blown right off the side of the mountain. When it was all over with, next morning, got up, tried to make a few more contacts, and Wes found out that his rig was pretty well shot. At least some of the parts of it, the switches were all gritty, and the Johnson Brothers drive, which ran the variable capacitor, was all ruined, and he had to replace those. It seemed that the wind had sifted the finest of the ash through the fabric of the tent, so that the inside of the tent was covered with a fair film of the very finest ash, which got into everything. So that hooked me. That was a QRP field day, the first time I'd ever done a QRP field day. And the idea of backpacking all the gear up to a site and doing the operating with low power really excited me. And so I did that exclusively for the next 40 years or so, every year, and have Wes to thank directly for that. And here's Wes, and I've never seen him without an ice axe. I'll bet you still carry one, Wes. This was a solar panel. This is a very old photo. This is a solar panel I brought so that I could run solar power, and I had an antenna, which I'll talk about a little more later, which used this PVC pipe for spreaders, and we had a good collection of stuff, and found a nice little spot near Mount Hood, which is a very scenic spot. We operated from that one place many times. And there's our crew at the time. My beard is a different color. Wes seems to have a little more hair. And so's Roger. But we all went up there and operated many times. And some of the other folks have been up there with me since too. Roger and I found that place. We went scouting one time and looked at some candidate spots and stumbled into that one, and it was really nice. It's a little bare knob that sticks up there, and it's really good. There's the scene. There's the view of Mount Hood from it. And here's a little extra knob that sticks up a little higher yet, looks down on our campsite. Our campsite's down in here, and there's my field day special antenna, which again I'll talk about a little more later on. But that's what we see. We're looking roughly east there, so we have a good shot out to the east with no mountains really that are much higher than we are, at least none that are close. Roger got up on the top of the little knob there with a homemade quad and operated a little 2 meters. The only time we've ever run any VHF from up there. And that made a nice scenic shot. There's the rotator we used. Okay, now we'll forward a little bit to 1980 or so. And during the early part of this period, somewhere around in there, that I did this with Wes for a number of years. And each year, I noticed that Wes was kind of getting quieter and not being very happy about things. And that really bothered me. I really like Wes and have a great deal of respect for him. And he's the guy that got me started in the whole thing the whole thing altogether. And I couldn't figure out what was the problem, so I asked him. And it turns out that Wes's idea of field day is more of an adjunct to mountain climbing. What you do is it's basically a mountain climbing exercise where you go and climb up to the top of a peak somewhere, and maybe on Sunday morning, get out a homebrew rig, throw the antenna over a tree branch and operate. And what I had evolved to was making more and more elaborate antennas, trying to work more stations and make my station more efficient. And it became a bigger and bigger deal, which turns out just wasn't his style at all. So we parted ways for field day, and he's gone his way and I've gone mine, and we both enjoyed ourselves very much. And it's worked out fine. But that's one thing I would suggest that people who do this kind of thing kind of work out and think about is the people you go with. Do you have the same goals? Are you really after the same thing or not? And if not, then it's better that you probably do things separately. And that worked for us. And since then, I've done most of my field days either with Dave DeFord, shown here, or Tom Rousseau, and both of those again are here listening, and will keep me honest, I hope. This right here is a 40-meter version of the field day special antenna. I got the rope up about 90 feet, roughly 30 meters with the slingshot. Let's see, the Brits call it a catapult, and hoisted it up. And this one particular year, we had that kind of a 2-element antenna for 40, 20, and 15, and we drove up with a car for that one instead of packing it in. And we actually were top in our class that one year. I've never been top in my class before or since, but considering that there's no special class for people who schlep their own gear in, I think we do quite well by usually being around 5th or thereabouts in the ratings. We'd bring along our kids when Dave and his wife would come, and I and my wife, and both of and we each have 2 kids, and they both came with us. Those are my 2, playing blind man's bluff, it looks like. And my son there, Sam, is now 44, 43 or so, and Robin is 47. So that was a long time ago, but they had a lot of fun. And there's Dave's son, Stephen, who's now a emergency room physician, and Sam, who's a programmer, and my son. So it was a long time ago. We'd go up on the side of Crater Lake and find a nice spot one time we were interrupted in the morning just as we were packing up to leave by a herd of cattle that came through to graze, and we had to pick things up really fast before they got all torn up. Another time, Dave and I were sitting there at about 2 in the morning outside with our headsets on working CW, and we heard this and what was that? And we took off the headphones, and it happened again. It was apparently, I'm quite sure it was a cougar that was either announcing something about its territory or having some kind of a dispute with another one. Never saw it, never have seen a cougar up here. Okay, then a while later, Dave got a pilot's license and built an airplane. He built this airplane, and actually the two of us flew to Alaska on another trip together in that plane with Dave flying. And one time we decided we would meet at a site down south of Portland, pretty close to Crater Lake. And Dave was to fly down and I was to drive down. It was before I got my own pilot's license, and meet up. And Dave was delayed, so I drove about 40 or 50 miles or so south to Klamath Falls to find a room down there. The room we had hoped to reserve right close by there wasn't available because of a model railroad fan convention that took place every year. So I took off and I drove down to Klamath Falls, and it was just getting dark as I was coming back. And I drove by this long swampy lake, Klamath Lake, and the mosquitoes were so thick that I had to use my windshield washers to clear the windshield enough so that I could see where I was going. This is what my car looked like after I got up to the place where Dave was. So that's a cautionary note about the mosquitoes, although we'd already seen some really bad ones. And when we picked our spot, for a field day that was a long ways away from the lake. This is Crater Lake. It's the rim there is about 7,000 feet or so, and it's really scenic. And we did our operating from the flank of the mountain. In fact, that's the spot we picked, just a nice little spot in the woods. And that was another one which we didn't pack in very far for. And then after I got my pilot's license and my airplane, that's my little airplane right there, and there's Dave with his airplane. We flew into a nice town called Prospect, Oregon, which is along the Rogue River. And we got our stuff in some backpacks and hiked about a mile or so out into the woods and operated from there. And we've tried to do that a few other times, and with limited success. I think we went to Prospect one other time, and those are the only 2 times that we've managed to fly into someplace. One problem is that so many of these airports are down in the valley. They're not on top of a peak. So if we did fly into someplace, we'd have to schlep quite a ways up the mountain. And unfortunately, we're not getting any younger. and then so when we went to Prospect, I went to snoop around and scout. Dave was delayed again, and so I decided to take the time and go scout for a possible field day location. And I was hiking along in this kind of a sparsely wooded area. It had been logged some time ago, and I saw that right there in that picture, and it was a grizzly bear. And we don't have grizzly bears around here or around there. We have black bears, but that sure, with the nose and so forth, looked an awful lot like a grizzly. And I spent 6 years in Alaska, so I'm quite familiar with bears and various kinds, and knew that the only way I could survive if it decided to dislike me was to find some kind of a tree to climb, and there, as you can see, there wasn't anything around. So I was just kind of frozen and thinking about plan B and plan C and not coming up with anything at all. And then I noticed that it hadn't moved, and so I looked at it really carefully, and I was sure that thing was a bear. And I looked at it again, and I finally walked around and discovered that it was a stump, and it was the scariest looking stump I ever saw in my life. Here's a typical operating position. We use clipboards, which are just pieces of corrugated plastic, kind used for making signs. It's very rigid and very lightweight, and just some clips on the top, and put the sheets of paper on it, and they work very well. That right there, maybe you can see the little laser spot a little easier. That is my rig. It's a 15 meter super hat rig transceiver that I designed and built just for field day, and it works super well. I'm very, very happy with it. It's got the nicest AGC of any rig I've ever used. 400 hertz bandwidth or so on CW. A nice supplied me the matched crystals for it. And enough tent like this thing here where we can actually sit in it at night on folding chairs and operate in the shelter. But we only had the backpacking tent that time, and so we had to operate outside, and I had to quit operating when my fingers literally got too numb to run the keyer. And here's a Now that one there was just a couple of years ago in 2020 during the pandemic. I went up to a site that Tom Rousseau and I have gone to quite a number of times. I went up there with Dave also. It's up behind Hood River, Oregon. And there was a forecast. The forecast was pretty good as far as rain and stuff went, but I didn't miles an hour. And I got my antennas up somehow the evening before and went to operate. I got out my little folding chair and all my super lightweight stuff and got it out and set it up. And every time I'd try to operate, a big gust would come along and tip over the radio and tip over the table and that kind of stuff. And I finally gave up and I think I worked 2 stations or something and went back home. So that was just not a very good time for field day. One of my secrets for doing field day is my bulletproof list. I've got these lists for other occasions also. When I do cross-country flights in my airplane, I've got similar lists for the things I need for that, or camping under the wing and that kind of stuff. And this list was developed over years. Every time I go, I find something that is new or different or changed. For example, maybe I need some more medications that I didn't used to put in my hearing aids and so forth. So power suits me fine. What I do is my rig current consumption is a bit under 200 milliamps on receive, and when I'm transmitting about half the time or a little less, and about half of that time is actual key down. So I've figured that I average about 200 milliamps. And so my solar panel provides about 200 milliamps during the day, which keeps up with the current drain from the rig. And so when the sun goes down at night, then I've got a fully charged battery, and I can operate. If I have a 2 amp hour battery, I can operate for 10 hours overnight with it, which is enough. And so that's the way I figure it. And so these are all in that general category. This one here is a bit bigger. This one here is, I think, a 5 amp hour. But this one here actually has, I did it again. I went to point and I clicked it. Okay. This was 11. This is 11 A-size nickel cadmium batteries. And a really nice thing about nickel cadmium batteries is they'll tolerate a 10% overcharge just about indefinitely. So I can hook that to the solar panel and not worry about it overcharging or being damaged by overcharge, and not have any regulation whatsoever. If it ever reached full charge and the solar panel just sat there and pumped a couple hundred milliamps into it, no problem. And the way I handled the varying voltage, of course, when it's fully charged and getting solar panel stuff in 200 milliamps into it, the voltage goes up to more than 1.5 volts per cell, which can be too high. Maybe not for your situation, but the way I solved that problem is I tapped it at 10 cells and 9 cells. And so while it's actively charging, I would hook up to the 9 cell tap. And then at night, as the voltage would start to drop, I would go to the 10 and 11 cell tap. And that's the simplest system. Then I decided I wanted to try using lithium-ion batteries when they became available. By the way, you can do the same trick with nickel metal hydride batteries. They really will tolerate a 10% overcharge for a while without any real damage, I found. And you don't need to worry about it. If you're going to step away from the rig for quite a while to eat lunch or something, you can just unplug it there while the solar panel's on it. And not to worry about it too much. So, and modern AA cells have close to 2 amp hours of capacity. This is 3 cells of lithium ion. This is actually a lithium polymer battery. And that puts out something like 11.7 volts during most of its discharge cycle. And it goes up to, 14.2, I think, when it's fully charged. But in order to charge that, you've got to have a voltage limited supply. You have to have a pretty good voltage regulator to charge that, as you do with the lead acid battery. That requires a constant voltage charger also. Finally, this is become my favorite, and this is a lithium iron battery, lithium iron phosphate. And they're really nice. They have an extremely flat discharge curve. The voltage changes very little. A 4-cell one sits there at about 12.6 or 8 volts for most of its discharge time. And the voltage on at full charge doesn't get very high. And they're a lot safer than regular lithium ion batteries. And it's just got everything going for it, except for they cost about, 4 times as much as the lithium ions. So that's my favorite, but the expense is the one downside to those. And they also, of course, require a charger that is pretty precisely voltage limited. And I just wanted to mention, I've got, you can see a fuse holder here on a couple of these all built on. And for the ones that don't have a fuse holder, here's just a little extension of fuse holders, a couple of different kinds. And I'm going to talk about the importance of those in a couple of minutes. These are just a couple accessories that I sometimes take and sometimes don't. This is a little directional watt meter, which can be handy. And this is a transmatch. And this transmatch is based on a design from Wes's book, Solid State Design for the Radio Amateur. And it works very well. It's got a little T match in it, one inductor and a couple of capacitors. And the band switch just changes the tap on the inductor. And it's got a little bridge for tuning, a little resistive bridge. And that works quite well and is reasonably efficient. You lose very little power with it. This directional watt meter was described. I wrote up an article on that in QST years ago. And let's see, that might be on my website, easyneck.com. This is my battery charger, voltage regulator, and one of the features of it is that it was really initially designed to work with the 3-cell lithium-ion battery, which is great for the solar panel. You can hook the solar panel. The solar panel provides enough voltage for it, whereas it doesn't really provide enough voltage to charge a 4-cell one. And as it's discharging, the 11.6 or 11.7 volts isn't quite enough to keep my homemade rig happy on 15 meters. So I need more voltage. So what I do is I have one of those little very cheap Chinese boost regulators inside it with some extra filtering on the input and output to keep down the RFI. And so I can switch it on to boost right here. And that'll get it up to 14 or so volts, which is what my rig really likes to have. And so that's something that I use with either that or the lithium iron phosphate batteries. For tables, boy, we did all kinds of things about tables, and I tried to cut this talk back a little bit, and so I didn't show some of the iterations. Dave created a very nice table. Wes made one up with some rods and a piece of plywood, and Dave constructed one pretty much from scratch that all folded up really nice and small and was lightweight. We used those various times, but what I finally settled on was this little triangular folding stool, which is aluminum, and it's extremely lightweight. And then I just set this piece of corrugated plastic on top of it, and it works fine, so long as you keep your weight sort of in the middle of it and don't put too much stuff around the edge. So that's what I've used for quite some time now. It sure didn't work in that wind that I showed you with the tent, though. Here's the toolkit I always take along, and this is a really neat thing. It's a butane powered soldering iron, and some solder, a little bit of wire, various kinds, a couple of clip leads, tape, wire cutters, some hemostat clamps, a little teeny screwdriver, and an assortment of little transistors and diodes and capacitors and a few things like that, and a multimeter. And I have used every one. Oh, and here's a little wire nut too. Those little teeny wire nuts are really handy. And some glasses. These are like reading glasses that are 4x power, so you can use them for just magnifying. And I've used every one of these tools at one field day or another. And the whole kit doesn't weigh very much and doesn't take up much room. But boy, if they come in handy. Oh yes, this little thing here. I can hear Tom chuckling, even though he's got his mic muted. Tom Rousseau and I were up on the hill one field day, and it was just turning dark, and I was sitting in there. Oh, and let me preface this story just a little bit. I always had a fuse in series with my battery, and I was getting ready for field day the night before, and the fuse holder broke, and I didn't have another fuse holder. And so I thought, well, you know, I've been carrying this thing around for 20 years or 30 years or something, and don't have I've never needed the fuse. The fuse is never blown, so I can surely get away with it this one time. So I had also just put a switch in the 2015 meter rig for the first time, a power switch. Before you just it came on and I plugged it in, but I got fancy and put the switch on there. So we went up to field day, and it was just getting dark, and I was just plugging in the rig in order to make sure everything was working because we just had our antennas up and so forth. And Tom steps into the tent with his headlamp on, and I see smoke in the light from his headlamp. And I thought, oh, something's wrong with his headlamp. And then I realized, no, the smoke is coming from below the headlamp. It's coming from this wire that is connecting my battery to my rig. And I just have these banana plugs for power. And these wires in this little ribbon cable separated. They dropped right out of the insulation and hit the tent and burned some holes in the tent. There's one, or the tent floor. There's one right there, and there's another one right there. And it turns out that I'd plugged in the banana plugs backwards. And I had this crowbar diode, which was a diode hooked around backwards to prevent the rig, to save the rig if you got the power backwards. And so what happened is that there was an immediate short circuit on this from this battery. I think it was a lead acid battery, and it was putting out a gazillion amps. And of course, I yanked it out. And fortunately, number one, the power switch was turned off, so the rig never got the backwards power. It was just the diode that was hooked right directly across the power connection. Also, though, there was this tantalum capacitor across there. And what I found out when I opened things up is that the diode had protected it maybe for a few seconds, but then it was totally cremated. There was, all that was left of the diode was the leads hanging there, and it had actually gotten hot enough to melt the solder, and they were drooping down. But the tantalum capacitor, which had the reverse voltage applied across it, was still intact and was a very good short. So it was actually the tantalum capacitor that did the protection. So I thought that was kind of interesting. Anyway, that was one of the times. Another time we were, again, Tom and I were up at the same site, I think it was. And we got into some lightning, which is unusual around here, but we had some lightning. And we were getting these big voltages induced into the antenna. And I disconnected the antenna when it got kind of close, but I wasn't quite fast enough. And all of a sudden my rig quit working on one band, and I went and troubleshot it and found out it was a diode that had been blown in there that was used only on 15 meters. And so I replaced the diode from my little kit using the soldering iron. And finally, the most interesting one was when Dave and I went out one time, and I turned on the sideband rig, and all I was hearing was sideband stations. And I came to realize that the frequency was off by a couple hundred kilohertz. And I couldn't figure that one out right off. There's a frequency shift in the thing when you go from one band to the other at about that amount. I thought that was involved. But what it turned out to be was I finally found it. It was a broken trimmer capacitor, a little air trimmer that had physically broken. And so I thought, okay, what am I going to do now? What am I going to replace this with? Because I had a very limited amount of that kind of stuff in the kit. And I thought, well, how about some coax? And I've got some RG 174 1/8 inch diameter coax here. And I know that 50 ohm coax is about 30 puff per foot. And I eyeballed it and guessed it was, I don't know, 20 or 30 puff or something like that. So I cut off what I figured was about the right length and just an open stub, if you will, and soldered it on. And by golly, it put us right on frequency, and we operated the whole rest of the contest with this piece of coax hanging out the back. Now, let's see. I am getting right around 9:30. I think I got started a little late. I don't want to goof up the whole system here. So, Farhan, if you can somehow shout at me when we are getting close. I hope I can hear you. I don't know if I can. Maybe I'll need to drop back to the main screen here in a moment. What I'll do is I'll maybe run for another 10 minutes and see if, because yeah, I hear something. So it sounds like you can flag me you need
Hey,
me to.
hang on, guys. I need to know how to turn the mic around. Give me a
Yeah,
second.
yeah, I hear you.
Okay, will this work? You guys can see me. Hang on. I've
I'll, I'll,
turned
con-
my
I'll continue on here while you get it together. Uh, the U.S. Field Day, we've got an international audience here. You may not be acquainted with U.S. Field Day. It's for United States and Canada stations.
continues.
And I want to let you other folks know that we people who are operating U.S. Field Day welcome DX stations. You can't participate in the contest um, by getting scores and getting published in QST, but you can still make contacts, and we can get 1 point for the contact, just like we normally do for any U.S. contact. So we welcome any DX. You just all it is on CW and phone is just signal report, and you would use DX for your the rest of your reply, and that would be it. And I've worked a few Europeans during field day. This is so field day being for the U.S. The problem is for me is that where I am is right there. And this is a map of the population of the US. And as you can see, I'm here and the people are there. And so the problem is to get antennas that will reach that, being that I limit myself to 5 watts output. And to give you an idea of what kind of distances we're talking about here, here are some typical distances. The nearest really good bunch of people, except for Los Angeles, starts about here, which is going on 3,000 kilometers. And to reach New England, which has got a whole bunch of people up there, now we're talking 4,000 kilometers, and likewise down here in Florida. So what kind of an antenna do I use to reach these people? I got to approach this like DX. The angles that I need to achieve for good efficiency is down around a couple of degrees. So I can't have high angle signals will bounce many times and not be nearly as effective. So it's just like a DX problem. So the antenna I use has this kind of a pattern. Now this is kind of misleading because it's a different scale and everything else, but it just gives you a general idea. I've got an antenna that doesn't waste much out the back. This lobe really doesn't have much power in it. So most of my power is in the forward lobe. And I told it down just a little bit more than it shows here so that I cover most of the US. I'm skimpy down here around California, which is useful, bunch of stations. But otherwise, I miss a little bit in here, in southern New Mexico and so forth. But the big population center I hit very well. Plus, I hit into the populated parts of Canada, up around Montreal and so forth, in Ontario. And so that's what I use for an antenna for 20 and 15 meters. It looks like this. That's my field day special antenna. It's a 2-element beam. It's kind of like a field day special, except for it's designed a little differently. And you can actually make it so that you can switch directions on it by putting another feed line down and leaving one open. If you make them the right length, you can leave one open circuit and the other one fed. And of course, for field day, there's nobody really out back as far as U.S. and Canada is concerned, except for Alaska and Hawaii, and actually those 2 rear lobes pick them up well enough. So you've got these spreaders, which are 8 feet long and are just made out of PVC pipe. And then later on, I decided, gee, it'd be cool if I could have a 15-meter antenna. This is a 20-meter antenna, and I have a 15-meter antenna. So what I did was I I took and I made a Yagi, a 15-meter Yagi, inverted V kind of Yagi, where this is one element right here, and that's the driven element, and this is the reflector right here. And I had to fiddle the feed point a little bit to make a matching network so it would match on both bands. And this is just held down by some rocks or weights. And so it still only requires these two supports to hold up, one on each end, and that's it. And so it goes up relatively quickly and down, and you only need to shoot two ropes over trees. And so I've been using that for a long, long time, and I used one from home for quite a while that was reversible. Now here, after a while, we wanted to cut down weight even more, so we started using a tree branch that we picked up for the spreaders. They don't really have much, they don't have to be very strong, really. There's not much bending moment to them, and they just need to kind of hold things apart. And then you can use rocks for these weights right here and end up not having to carry quite so much stuff. To get California, I generally put up another dipole, and I have I've used a couple of variations. This one here is a 40 and 15 meter dipole with a trap right here. And then a 15 meter, or the 20 meters is a separate dipole that's hung down underneath like that. And that's because I couldn't, with the kind of traps I was using, which was little coax traps made with RG-174, I couldn't get enough Q on them. I lost an unacceptable amount of power on one band or another when I tried to use them for 20 meters also. Later on, I came up with traps that would work better, and I just have a single wire. But this also goes up just with two supports, because this string here, this is just some of that twine, goes on up to the support. This is the whole field day special, including the 15-meter Yagi right here. This is it. And this is the dipole I'm using now, which is 40, 20, and 15. The traps use little powdered iron cores and silver mica capacitors. This is a Vallon at the feed point. And so you can see that weighs very, very little and takes up very little room. Then that's my whole station. It's really amazing. It's absolutely amazing when I'm operating. I can switch over the dipole and just start tuning, and all the loud stations are California. And then I switch back to the field day special, and they're not. Here are some ideas. RG-174 has about 9/10 of a dB loss at 50 feet. You'll find that RG-58 comes in at, I don't remember, 6/10 or something like that. So you only lose a few tenths of a dB. Now, I have to say every dB counts when you're down right at the noise level, which you often are with QRP. So I usually do use RG-58 feed line. I looked at RG-8X, which has slightly less loss than RG-58, but it weighs considerably more. So I pretty much settled on RG-58 for my feed lines. Once in a while, I'll use this. I operated 80 a couple of times and used this stuff for 80, but 80 meters, people don't hear me because of the noise. So I've given up on that for the US. This is a little center insulator, which is very universal. What you can do with this guy is it's got a BNC connector there for your feed line. It's got a Vallon right here. And then you can take any number of dipoles and just feed the wires back and forth through these things for strain relief, kind of like they're done, like it's done here. And you can put 2 or 3 different dipoles at different frequencies. Of course, if you do that, you need 2 supports for each, 2 extra supports for each dipole, unless you make up some kind of spreader to spread out the ends of them. Here we are using the slingshot to put it up. Done like that. Once in a while, one gets hung in a tree. I believe that's Ron. That's Wes's older brother. He's now, last I heard, he was an airline pilot. He might be old enough to retire now. I don't know. Climbing up to get one unhooked. I'm afraid I've left just a few weights dangling in trees. They're painted blaze orange, fluorescent orange, and so I'm sure that people have wondered from time to time what this fluorescent orange fishing weight is doing up in a tree 20 feet above the ground and miles and miles from any lake. Okay, this is just a couple of shots of us operating there. Typical setup. There's the table in use that I was describing. This is Tom Rousseau, K7PJT, doing the logging. We switch off. And there's Dave. There's the table that Dave made. That's a very nice little table, but ended up with a smaller and lighter one. The main thing for field day is to have fun, and be sure you do that. It's really been my almost only ham radio activity for many years, and I still enjoy doing it. The backpacking is kind of settled down a bit. Knees and backs and stuff like that start complaining at a certain age, and I'm at that age, or maybe a little past it. And likewise for most of my field day partners, Tom Rousseau being an exception. But the rest of them, I think, are kind of over the schlepping up 60-pound packs and stuff like that up the hill. But you can do it Wes's way and just take a little QRP rig and stick it in your rucksack and go up to the top of the mountain and still have fun. So that concludes my talk. Here are a couple of links for Field Day Special Antenna if you want to learn more about that. There's a very, very old DOS program for designing it. I've been wanting to rewrite that for Windows, and I've partially finished, but it just keeps pushing itself down on the list, so I haven't finished it. And if you're interested in any kind of antenna analysis, by all means, download my EasyNet antenna analysis program. I retired last January, at which time I uploaded the professional version of the program with some extra features beyond the EasyNet program of the time. And at last, and it's free, it's completely free, no charge. However, there is no support. That's the price. You get it free, but you get no support. I'm retired. But at last count, just a couple of days ago, I looked, and about 27,000 copies have been downloaded so far. That concludes my talk. Thank you very much. I'd be glad to answer questions, but I'm probably don't have time for
that. Thanks so much, Roy. That was phenomenal, and what a blast. But I was just wondering if Tom West, Roger would like to pitch in and say a couple of words or add to what you've said before we can take questions. The next session, whoever was doing it has not turned up, so we have time now, and we can probably extend the discussion for a little bit more.
Great. Yeah. Okay. Now, good. Roger and Wes and Dave and Tom can all tell you that it will all be yes. So here we go.
Well, I'll give some credit to the very, very tall trees in Oregon and the areas we usually go to. Roy's antennas are fabulous, but one time we hoisted an antenna up, had a center feed line on it that had it was 100 feet, so 30 meters of feed line, and we could just reach it from the ground. So they got up very high, and we had excellent locations in the mountains, always choosing a location that faced in the right direction for good propagation. So we used everything we could to get good signals out.
I forgot to mention, you can really gain a huge amount of signal strength, low angles, by choosing a site that slopes kind of gently in the direction that you want to transmit. You can get by with quite low antennas if you do that, and it really helps. You can pick up 10 dB or more easily by doing that.
Well, I'll pipe in here. This is the quiet period. Roy invited me to a field day. I guess it was around 87 or 88, and it was the first time I'd done a low power field day. I'd done 100-watt field days before, but not with 5 watts. And I just was amazed. I think Roy can probably still remember me dancing around the field day site with joy and glee that we could make contacts. We made hundreds of contacts, at least 300 contacts on QRP with 5 watts. And to me, that just highlighted the magic of radio, that you can talk to somebody halfway around the world with the same amount of energy it takes to walk to the mailbox.
Yeah, I remember that, Tom, and I remember that one of the stations we worked was a DL, and that really impressed you. That was a guy that came through a German station, and I typically work around 300 contacts or so. The best I've ever done was one year when I went by myself, actually, and I worked more than 600 contacts. That's my all-time record, but typically 300 or thereabouts is more typical. Puts us somewhere around between 4th and 5th place usually in the list. We're competing with the stations that are going up and driving their cars up and putting up big towers and beams and other stuff. There's no special category for people who haul it up themselves. Hello. Anybody else? Come on, there's got to be some questions. Can the audience ask questions? Is there a way to do that? Ashar, your mic is muted. Still muted.
All right. Okay. Now
Yeah.
I guess you guys can hear me, right?
Yep, I can hear you now.
Okay. So, hang on. Just on a bit. Hello.
Hello.
Yeah. So there are quite a few people who would like to ask you guys questions. No, I know. I've just muted this. So what we'll do is we'll type out the questions here, so that there's no, feedback loop, because this is a big hall, and you guys are about 500 people here actually, and it's sort of echoing if I put you guys on here. So what we are going to do is we are going to take these questions and type them out here, and then some of you can take the questions on. All right. So you'll just have to open your message list there to look at the questions. All right.
Right. Okay, I see a question here from VU2. Oops, one away. I saw it for a moment and then it disappeared. Let's see, there's a. It just showed up for a couple of seconds there, Farhan. I don't know where it went. I'm
Well,
sorry.
I can relay it here. I've got it. It's from Victor United to James Whiskey Beta. The name is Teha. He's asking, what are the differences in the noise levels when you operate the QRP from home and in the field?
It's really quite a bit. However, most of my operating on field day is 20 and 15 meters, which are fairly low noise even at home. I don't have a very noisy environment, or didn't used to have a very noisy environment. Right now, my 80 meters is completely wiped out, and 40 meters isn't too hot. So it can be at least 10 dB. And that's one of the really nice things about going out on field days. You can get to where it's really, really quiet. Thanks, Roger.
Yeah, Roy, there's a flag in the lower right for me, just to the right of the 8 people connected. The next icon over, if you click on that, it should pull up the in-call messages on the right side of the screen.
Got it. Chat with everyone. Okay.
Okay, so
thank you.
hello.
Hello. Yeah, I got it. I can see the messages now. So all I need now is the messages.
Let's see if I can.
Okay, VU2, TJ, Thomas. What are your favorite modes and bands? Okay, CW is my favorite mode. I went to all homebrew equipment, and I prefer CW for operating anyway. And CW rig is way more easy to make than a sideband rig, and you can do a lot more with the really low power. So CW is definitely my thing for QRP operating, especially. Bands for field day is 20, 15, and 40. I typically start out on 15 meters if it's open. 20 meters I can get on and run with the big dogs. However, the competition is really heavy, especially early in the contest. Everybody jumps in, and there's a lot of power on the band, and sometimes it's kind of hard to compete and be heard. Whereas on 15, my signal is a lot stronger, and if you'll note, you don't seem to notice an awful lot of difference between the powerful stations and the weak ones. And so I start on 15, and then after I clean up the band, that is, I'd say I tune up and down the band a few times, and I work that guy, work that guy, work that guy. So then I go to 20, and then I operate 20 pretty much until 20 falls out, which it does typically somewhere around dark or a bit after dark, and then I go to 40 and operate 40 for the rest of the night. 80 just doesn't work in the U.S. For me at my location, because the people in the populated areas of the country are fairly close to thunderstorms in the Gulf of Mexico. There are always some really bad thunderstorms there in the summertime. And also in the Midwest, there are typically thunderstorms. They have a lot of QRN. And I am a little PP signal on the other side of that stuff. So they just don't hear me. I hear a lot of people, call a lot of people, nobody comes back, or they just barely hear me. So I don't try 80. So that's the answer there. I've never tried 10 meters. Maybe when the sunspots get really hot, someday I'll try that. But that's the best answer I've got right now. Wes's favorite has been 40 meters on field day. But I guess Jeff Dom did operate a lot of double sideband and on higher bands. Here's my latest field rig. Wes, you might want to answer that one.
Oh, with regard to bands?
Yeah, Farhan says your favorite band has been 40 meters on field day, and if you like to operate in the daytime, that's pretty good.
Oh, yeah. 40 is really great for up and down the coast here on the West Coast. You guys copying me okay?
Yeah.
Okay. 40 is great up and down the coast. And 20 is fine, but like you say, it can be terribly crowded. 15 can be a real surprise. One comment, though, I remember some of the contests that you and I did, Roy. We worked 20 meters well into the evening hours to midnight or later. And we got to the point where we were working Europeans, but still working all of this country. And that may happen again if if the sunspots cooperate a little bit. Also, I've worked single sideband a little bit on field day, not nearly as much as CW, but the sideband can be fun. It's more of a challenge, but it can be fun. And okay, the single sideband gear is really a lot of fun to build and to get going, operating on the air. I like the people I run into on CW better, but but I guess I'm elitist in that regard.
Yeah, I did one field day where I operated only 40 meters. I had my little optimized rig, and then a 5-watt amplifier, and I used that only on 40 meters. And 40 meters, like I said, is great up and down the coast, which means 1,000 kilometers or so. And daytime skip, it is mostly NVIS kind of stuff. So you've got high angles, and low antennas work just fine on 40 in the daytime for these limited distances.
Yeah. On the antenna thing, I bet Moxon antennas would be a very good bet these days. Also, it's again a 2-element antenna with fairly close spacing and lightweight, wire antennas, and I bet they would do quite a good job.
Yeah, I didn't mention that I didn't go to a more elaborate antenna with more gain because that would mean a narrower pattern. And since I couldn't rotate the antenna, I wanted to cover basically all of the populated U.S. without having to rotate it. If you could rotate an antenna, more gain is better, but I couldn't. So,
well, Moxons have a pretty wide pattern.
Yeah.
I would guess they would be quite similar to your field day special.
Mm-hmm. Yeah. Pretty much all the 2-element antennas are in the same ballpark.
Yeah.
Okay, we have here VU2XZ. Sashi, the current popular antennas are EFHW. Have you guys ever had any experience with those? I'm sorry, I don't know what EFHW is.
In-fed half wave.
Oh, in-fed half wave.
Yeah.
I have experience with those. That's the kind of antenna I used when I first started in ham radio. I had one going out to the clothesline pole behind the house, and it went through the window into a little tuning unit there and sitting on the shelf. And my friend was one day leaning up against the shelves, and he says, "Hey, Roy, I think I smell something." And he looks over, and his thumb is smoking, and he's got it leaned against the end of the antenna. And I was running about 15 watts or something like that, but that was plenty to cook his thumb. Nothing wrong with end-fed antennas. One thing is, if you got something like a vertical, you get by with a very abbreviated ground system. Obviously, you need to do some serious impedance matching.
A friend of ours, Bob Coulter, N7FKI, has done a lot on field day with in-fed half waves, and he uses I think a 9-to-1 turns ratio toroid transformer. We found that it's best to wind them on type 61 cores. Type 43 cores work, but with a dB or so, dB and a half more loss than the type 61 cores. The other thing that Bob found that is really practical and yet very significant is that you want you have the transformer at the end. Then you want to put in a common mode choke. That, of course, you can wind on 43 cores, but a common mode choke to feed it, and then put a couple of feet of wire on the so-called reference side of the end-fed half wave, and you can actually position these very short radials in order to fine tune the antenna. And once you've done that, then the automatic antenna tuners that are built into the appliances these days will allow you to move around within the band. You want to also be careful of people talk about end-fed half waves, and they're talking about antennas that are often in half waves rather than just a half wave. Bob usually runs just a single half wave antenna, and they're very easy to get up in a tree, but you don't have much control over pattern. Another antenna that Bob and I ran one year that was very effective was about a 50-foot dipole that was fed with I think 300 ohm line. I had some foam 300 ohm line, so the loss was really pretty low. But this is a takeoff on the thing that what's the name? Or the W4 fellow who passed away a few years ago that used to be your buddy, Roy.
Walt Maxwell, W4.
No. The philosophy prof.
Yeah, LB Seebeck.
Yeah. And anyway, he did an article where he said, if I could have but one antenna, what would it be? And it was a 44-foot dipole. And this had an unambiguous pattern on all bands from 40 through 10. He rotated the one he built, but it was a clean, unambiguous pattern. And on the higher bands, it had gain. Anyway, the one that I put up that year worked very well. It seemed to work fairly well. We didn't get it as high as I would have wanted it to be, but that's axiomatic. It's never as high as you want it to be.
Yeah, thanks, Wes, and that's really good stuff. I hope that anybody who's anticipating using an end-fed antenna should, if you've got EasyNet, look in the EasyNet manual, which is the help section of EasyNet, and look up end-fed antennas, because people somehow, when they go to model them, they stick a source right at the end of an antenna and wonder why it doesn't work, when, of course, one connection of the source is just open-circuited. And they don't realize that the feed line is the other part of the dipole. So they should read that, and what Wes says about putting the choke balun or choke in the line is absolutely essential. Otherwise, your feed line becomes, the outside of the feed line becomes part of the antenna. But and one other thing is that I use an end-fed half-wave antenna on 2 meters for a handy-talkie. They'll beat the pants off your quarter wavelength rubber ducky. Simply because of the rubber ducky, you're the other half of the antenna, and you're just pretty unpredictable and kind of lossy. Let's see. Farhan, Wes did some analysis of different matching units. And you want to talk about it?
Can you hear me now?
What's that, Farhan?
Can you hear me now?
Yeah.
All right, thank you. So, luckily what happened for us all was that the speaker who's going to come in next, he didn't turn up today. So we had an extra half an hour right now, and that was really wonderful. And I'm so glad Roy, that you could, pull in everybody, Tom and Dave and Wes and Roger. And I'm really thankful for you all. I will get back in touch with you. But, I think that we should do this regardless of whether we have a convention or not. That is, some of us can just get together and shoot breeze about what we've been doing. I think that would be a good thing to do. So let's think about that. And I thank you on behalf of the club and everybody, the 500 people here. So some of them are here, some of them are seeing you guys on monitors elsewhere, mostly home brewers. And they are gathered here. Some of them are picking up components, etc., from various places. But thank you once again for being up so late and being up with you all. And we've also recorded this. We will very shortly upload this on YouTube, and then we can probably put up on our websites because it's a very interesting discussion, full of history, full of technical inputs. So I thank you all once more, and I wish you all a very good night, and hope to see you all very soon down the line. Bye bye.
Thank you very much, and good evening, good morning to you.
Yeah.
Thanks
Okay,
for showing
take
up.
it easy.
Thanks for showing up on the short notice, guys. That's all.
Yeah, thanks for the buzz.
Yeah, thanks for the invite, Roy.
You bet. See you guys.
Did it?
Yeah, did.
What we do is we feed, because we've discussed that require, it can be defined as T cos omega T plus phi, or then what you do is you break it into two components. So half of it will represent the in-phase part of it, and half of it will represent the quadrature part of it. So when they are 90° out of phase, the resultant will be the signal that you really want. So this is your signal. What you're doing is you're breaking them into two parts. And then the two parts are going to ultimately math behind what the I and Q. So, and that is what is being used in our SDRs. Yeah. So one thing I would like to note here is that it is very important that the I and Q signals are 90° out of phase. If they are not in quadrature, then there is a chance that you will start seeing some DC. So when they are 90° out of phase, let's say there is some phase noise or whatever. So what will happen is you will start seeing some spectrum to the as an image. So it is really measure this as IQ mismatch. We call it, we define in terms of how much dB you are off from it. So ideally you should be in one particular location. Your resultant should be in one particular location, but you are drifting a bit. It could be your magnitude. Otherwise, it could start drifting if your load keeps on varying. So now once I get a square wave that is varying from 0 to 5 volts at the frequency of the oscillator at 14.3 megahertz, I'm going to get a square wave. Another IC which can generate half and quarter frequency outputs. So the 74393, this IC is going to, it's like a binary ripple counter. It is what by 8 signals and so on. So 14.318. So this 14.318 megahertz is going to come out as a sine wave. This is the tunable element that I'm talking about. Here actually I've missed adding to see a 14.318 megahertz sine wave. This is going to drive gate 7404. It's easily available, 7404 IC. So now the data is going to be 0 degree phase, because obviously your the data is at that data is coming from the 74393 IC. So that data and your clock are going to be in phase. But at the output of the D flip-flop, what's going to happen is there's going to be a delay. So this is in phase, and then there's going to be a delay. It's going to latch onto the, it's going to use the clock. It's going to wait for one clock cycle. And one clock cycle, because it's double the frequency of this one, is going to correspond to half of this. So it's going to correspond to half of this frequency. So the delay is going to be right in between its on cycle. So that's how you get a 90 degree phase shift between the two. Okay, so we'll go over some of the other components of the design. So now we have talked about the oscillator. So the oscillator, we have two outputs. One is I and one is Q. So those are going to feed into the mixer. Now, right at the front end, you will have an LNA, low noise amplifier. The low noise amplifier is supposed to give you very low noise figure. It's not supposed to add noise of its own into the system. So I use the 2N3904 amplifier and in common emitter configuration. Oscillator, we have two outputs. So, one is I and one is Q. Voltage. So those are going to feed into the mixer. So now, right at the front end, you will have an LNA, low noise amplifier. The low noise amplifier is supposed to give you very low noise figure. This is the circuit. It's not supposed to add noise of its own into the system. From the antenna, you get the. So you give it to 2N. I use the 2N3904 amplifier, and in common emitter getting configuration. The oscillator, so we have two outputs. One is I and one is Q. Voltage. So those are going to feed into the mixer. So now, right at the front end, you will have an LNA, low noise amplifier. Okay. The low noise amplifier is supposed to give you very low noise. Are supposed to be, this is the circuit, it's not supposed to add noise of its own into the system. One of the most difficult parts, the antenna you get the components to work with. You give it to I use the 2N394 amplifier. Mixers are used for frequency transmission. So even little bit of phase oscillator, any you have to output is going to rely on what your voltage. So those are going to feed into the mixer. Now, right, you can use front end, you will have an mixer to convert it into a lower amplifier is supposed to, you can give you very low noise, depends on what you're doing. This is the circuit, it's not supposed to add noise of its own into the system. Most difficult part in the receiver is going to be to work with. You give it to I use the 2N394. You can consider mixers as a switch for frequency transmission. You have even little bit of phase oscillator, any you have to output is going to rely on what your voltage. So those are going to feed into the mixer. Now, right, you can use front you will have an mixer to convert it to a lower amplifier through the base. You can give you very low noise, depends on what you're doing. Pass the circuit, it's not going to add off, it's going to stop. This is not going to pass on the antenna is going to work with connection between. I use the 2N394. You can consider mixers as a switch for frequency transmission. You have a little bit of phase oscillator, any you have to output is going to rely on what your voltage is passing through that one. Then my collector signal you can use have an mixer to convert it to a lower amplifier. You can give you converted into noise, depends on what you're doing. The outputs you have to decide on this is not going to pass on the antenna is going to work with because I use the 2N39 multiply with you can consider mixers as a switch of controlling little bit of phase oscillator, any you have to output is going to rely on what your voltage is passing through that one. The easiest type of mixer is you can use have mixer to convert it fast to a lower amplifier. You can give you converted into noise, depends on what you're doing. The outputs you have to decide on this is not going to pass on the antenna is going to work with because I use the 2N39 multiply with you can consider mixers as a switch of controlling little bit of phase oscillator, any you have to output is going to rely on what your voltage is passing through that one. The easiest type of mixer is you can use have mixer to convert it fast to a lower amplifier. You can give you converted into noise, depends on what you're doing. The outputs you have to decide on this is not going to pass on the antenna is going to work with because I use the 2N39 multiply with you can consider mixers as a switch of controlling little bit of phase oscillator, any you have to output is going to rely on what your voltage is passing through that one. The easiest type of mixer is you can use have mixer to convert it fast to a lower amplifier. You can give you converted into noise, depends on what you're doing. The outputs you have to decide on this is not going to pass on the antenna is going to work with because I use the 2N39 multiply with you can consider mixers as a switch of controlling little bit of phase oscillator, any you have to output is going to rely on what your voltage is passing through that one. I need to drop down the resistance value so that it more signal can pass through this. But I initially had the idea of using a low pass filter here, so before giving it to the audio amplifier. So these are NE5532 audio amplifiers. So it's a single chip dual amplifier IC. Okay. And then at the output, I get I and Q signals which can be fed directly into the laptop. Okay, next. Okay. So as I said, we'll touch upon some aspects of RF system design. So at the end, you are going to convert your analog signal into digital. And how you do it is you are going to sample it. So you are going to take the analog values, and for each analog value, you are going to give it some value in digital form. So if you have an 8-bit ADC, so 8 bits are going to represent some value at any point in time. So if it's 0, if your input voltage is 0, then it's going to be 0, 0, 0, 0, all 8 bits. If your input is like the maximum, which is like maybe like 3 volts, let's say, then your ADC output is going to read 1, 1, 1, 1 all the way. So that's how an ADC is going to convert your analog signal into digital form. So the speed at which it performs is important. Obviously, if you were to buy an ADC then you are going to look through all these characteristics. The speed of it, the resolution. So the resolution indicates how many bits are you going to use to represent a particular level. The more number of bits that you have, the more number of levels you can represent. And the more number of bits you are able to represent, the better the resolution you are going to get. So for a sine wave, if you are able to represent it with 8 bits, and if you compare that with 16 bits, you are going to sample it more number of times. You are going to get more number of bits to represent a particular level, and that is going to be, so in short, you are getting better resolution. The dynamic range, how many number of bits? So it's again, how much of voltage are you going to be able to represent? All right. The SNR, obviously you might have heard this term, the signal and the noise. Then effective number of bits. So what happens is the lowest, the LSBs, right, the lowest few bits are going to be drowned in noise. Though you are able to use 255 bits to represent a particular, 16 bits to represent a particular number, but ultimately you can use only 12 of them because 4 are anyway in noise. And spurious free dynamic range, you don't want any spurs. You want to characterize how much is your signal looking like compared to the highest spur. So that is another one. Yeah. Yeah. So I work in the wireless industry, and this is something that is very important when you design any radio. All right. So if you, I mean, for low frequencies, it's okay, but for as you move on into higher frequencies, this is what you need to take into consideration. So if you take any SDR and you plug it into your sound card, so you need to protect your sound card. There should not be too much of swing at the input. So that swing needs to be controlled. So what we are trying to control is the full scale voltage of the ADC. So how much peak to peak are you going to be allowing to the input? So there will be a maximum rating to each ADC. So you need to make sure that your radio is not going to exceed that. So it should not exceed 0 dB. So let's say my ADC requires 1 volt peak to peak at the input. Okay. So that is the full scale. We call it the full scale. And when we say my input signal is 0 dB compared to it, so in dBFS, so that means I'm already at the full scale. So let's say my input is 1 volt, that is rated, that's the full scale, and my input is 1 millivolt, so which is very low. Then I'm 60 dB down, so which is good. But if I go on increasing my input voltage, at one point I'll become 1 volt, and that's going to really ruin my ADC. So we should avoid that type of a scenario where our input signal is going to ruin the ADC's input. We need to protect the ADC. And that is what AGC is all about. We play with AGC just for protecting our ADC. So if there are jammers around, then it's going to make things worse for you. We need to take that also into account. But for now, we can just quickly go over a sheet. I'm going to give you an overview. Yes. Okay. I'm not sure if this is visible. Is this readable? No. Yeah. Okay. Fine. So I'm going to tell you a few things about the system design. The first thing is you are going to consider how much is your ADC input rated to be, so that maximum swing your ADC can take, let's say, is 1 volt peak to peak. Okay, so we are going to take that into account. Then the dynamic range of the ADC. So how much can your ADC operate in before getting drowned into noise. So your lowest signal that you are able to go in, that you can operate is 72 dB below what your rated operation is. Then we take thermal noise into account and then the dynamic range, and we can easily find out what the ADC noise floor is. Okay. Then I mentioned that I and Q should always be 90-degree apart from each other, right? So if there is a mismatch, what's going to happen is you're going to see a residual sideband. So that sideband, how big is a sideband, matters a lot, because that's going to act like an interferer. It's like noise for us. So that is known as RSB, residual sideband, and that is rated in terms of dBc. So if your carrier is at, let's say, 10 dBm, then your RSB that you're going to see is minus 20 dBc. Okay? So with respect to carrier, how down are you? How less is your RSB? That is what RSB indicates, dBc indicates. Then IPN, so that is the phase noise. Now, even if you turn off your carrier or your input signal and your LO is on, you'll listen to some hiss, isn't it? Because there's a phase noise. Every oscillator is going to drift a bit, and that is going to introduce a phase noise. So ultimately instead of being a single tone, like a sine wave, it's going to start looking like it's going to look like a Gaussian sort of thing. So that's because of phase noise. So that phase noise is always going to be present in your system. You cannot get rid of it. So that is something you need to take into account. Okay? And then, so we go through all these calculations. So at, let's say, minus 110 dBm of input signal, then we go through each of these calculations. I mean, I don't have time to, I think I'm really running short of time, but I just want to kind of indicate that each block in your system is going to contribute to some aspect of it. And ultimately, what we are going to see is how much is the swing, okay? If with these settings, how much is the swing? So ultimately, we want to make sure that I'm not exceeding 0 dBm at the input. So if I do that, then I'm going to, my ADC is going to be getting damaged. So we have to take steps. We have to set our gains accordingly so that our ADC does not get damaged. Okay. And a quick word about SNR, signal to noise ratio. So if you see, I talked about, there are two types of noises. So one is RSB and integrated phase noise. Now these two, let's say we have considered it as minus 30 dBm. Minus 30 and minus 30 will be minus 27. So you can never get SNR better than minus 27 because you're always going to be, no matter how much power you use, those two parameters are always going to be there. So you cannot exceed that. So SNR is going to get capped off at around 26 or 27 dBm. It's going to flatten out in spite of increasing the power. So finally, this is how the ADC, this is the process that we follow. Now let's say I start increasing the power, receive power, okay? My ADC swing is going to increase because there's more power coming into my system. My ADC is going to start seeing lot of power. The swing, the peak-to-peak voltage at my ADC input is going to increase. There will be a point when it's going to just be exactly equal to what its rated input is. At that point, our AGC, automatic gain control, is supposed to take steps such that my ADC doesn't get affected. So it's going to drop its gain. So instead of, let's say there was a 60 dB gain here, it's going to immediately go to the next LNA gain state. It will be minus 40, let's say 40 dB gain. So that's why you see a sudden drop in ADC input. And then again it starts rising. And then, so this is, so as I go on increasing my input level, I'm going to go on increase. So that's how my gains are going to go on changing. But my ADC is always going to be protected. So I think this is one aspect which requires some understanding, but it's pretty simple if you understand it from the ADC's point of view, when you are looking to protect the ADC. And that is very important when you're designing an SDR, because ultimately, no matter how much power you pump in, if it's going to blow up your input sound card or your ADC, then what's the point, right? So this is a small attempt to implement the AGC. So, so let's say at the audio output, right? So I see a lot of swing. The voltage, there's a high voltage coming in. So that I feed it as a feedback, and then these diodes are going to kind of allow only the negative cycle into the to this capacitor. So the voltage across this capacitor is going to vary. Now this bias voltage is going to vary according to the bias voltage on this capacitor, on the voltage around this capacitor. When the bias voltage, if there is an increase in the output, my bias voltage is going to decrease. So immediately there's a correction that is going to happen. And I tested this out. If I give a 2 volt input, then I see a negative 1.6. If I give a 1 volt output, and how it. Okay, I guess that's the last slide. All right. Fine. Thank you very much. Is there any question? Are there any questions which I can answer? Okay. All right. Thank you very much. Enjoy lunch. Oh, please. There's one more talk, I guess. Sorry. I forgot to show, this is the circuit I built. It's a pretty shabby one. This is the first time I was home brewing, and I did some ugly construction, and actually it turned out to be ugly. But it worked, so I guess I got the kick out of it. Thank you.
Check. Yeah, can I have your attention, please? Yeah, before we get into the next session, those of you who have not booked your food, if there is anyone who has not opted for food, there is a sale at the counter, so you can always buy your food coupon there. So you have to directly pay there and pick up your food coupon. It's already open. Food is open. Food counter is open. If anyone wants to have food, can go ahead and have food also. Thank you.